morning, students. In this series of the question, last set of the video, question number 26, conductivity of the cell has the cell constant of 0.5 per centimeter, and this cell was cell when filled with a 0.01 nm sodium chloride solution has a resistance of 0.384 ohm at 25 degrees Celsius. Calculate the equivalent conductance of the solution. So we know the formula, formula of equivalent conductance is equal to kappa into 1000 divided by molarity. So kappa is called as a equivalent conductance. Cell constant, G star asterisk mark is called as a cell constant. It is given 0.5 per centimeter, and molarity they have given 0.01. Resistance they have given as a 384 ohms. So all these values are given in the question itself. This is cell constant value, and this is a molarity value, and this is a resistance value. They are asking you to find out the equivalent conductance. Equivalent conductance is equal to kappa into 1000 by m. Kappa, we do not know the equivalent, conductivity. So this conductivity is formula is conductance into cell constant, but conductance is nothing but 1 by R. So resistance they have given. So K is equal to 1 by R into cell constant. R is nothing but 384 and cell constant is 0.5. So after simplifying, we are getting, substitute this straight away. 1 by 384 into 0.5 is the kappa value into 1000 divided by molarity value. So 500 divided by 384 into 0.1, we are getting 3.84. So we are getting 130.2 per ohm centimeter square gram per equivalent is the value. The 130.2. 130.2. This is the first answer, is the correct answer. Next question. Reduction potential of hydrogen oxide will be negative if all these values are given in this question. 2H plus 2 electron gives H2. So E cell is equal to E naught cell minus 0.059 divided by N log of H2 pressure divided by H plus N square. So for hydrogen, E naught cell is equal to 0. So E cell is equal to minus 0.059 divided by N log pressure hydrogen divided by H. Pressure is greater than H plus ion concentration. Substituting the values in the C option, E is equal to 0.0 minus E naught cell for hydrogen is 0 and 0.0591 divided by number of electrons 2 log of pressure is 2 divided by 1 square. The question, let us to see. In the C option, pressure is equal to 2 atmospheric pressure, hydrogen is equal to 1. Pressure is greater than H plus. So pressure is equal to hydrogen concentration is 1. So here when you divide this 2, we are getting minus 0.0295 into, 2 divided by 1 square 1 only, we will get a log 2. Log 2 value is equal to 0.3010. So multiplying these things, we are getting minus 8.875 10 to the power of minus 3. So E reduction will only be a negative. Pressure is greater than a H plus. So option C is correct answer. How many Faraday of electricity are required for the reaction to occur? MnO4 minus gives Mn2 plus. Here MnO4 minus 4 into 2, 8 minus 1, 7. So Mn is plus 7, here plus 2. The difference between plus 7 and plus 2 is 5. That 5 is nothing but 5 electron. We should put near the higher oxidation number side. This side Mn is plus 7, so we should put a plus 5 electrons here. 5 electrons means it is nothing but 5 Faraday. So here 5 Faraday, MnO4 minus 5 electrons. MnO4 minus Mn valency is plus 7, plus 2, Mn2 plus, difference is 5. That 5 should put near the higher oxidation number side. 5 moles is nothing but 5. The molar conductivity of 0.5 mole per decimeter cube solution of silver nitrate AgNO3 with electrolytic conductivity of 5.76 into the power of minus 7 Siemens per centimeter at 298 Kelvin. So here the question answer is, formula for a molar conductance, lambda m is equal to 1000 into kappa divided by m. So 1000 divided by m is 0.5. Kappa is called as a conductivity. Here already they have given us electrical conductivity 5.76 into 10 to the power of minus 3. So this 10 to the power, 1000 10 to the power of 3, and this is 10 to the power of minus 3 cancelled. So kappa value and molar value is given 0.576 divided by 0.5, we are getting 11.52. So 11.52 is the correct answer. Siemens centimeter square per mole. Last question, standard reduction electrode potential of three metals A, B, and C are for A plus 0.5 voltage, for B minus 3.0 voltage, C minus 1.2 voltage respectively. The reducing power of these metals are B is greater than C is greater than A, or A is greater than B is greater than C. Like that, the four different options they have given. By seeing the values, we can find out. Reducing power means reducing agent undergoes self-oxidation. So that is reducing potential is equal to very low value. Here are A value plus value, B value minus 3, and C value is minus 1. Very less values. First this one, B, second this one, third a positive answer. So B is greater than, C is greater than A is the reducing power. Thanks for watching, students. If you like, please subscribe, students, and also you can share to your friends also. Thank you.